Welcome everyone. In this section, in this video, we are going to do um, chapter 12, section 4, the cross product. So in the first three sections, we saw three-dimensional coordinate system and then how to represent a point in space. Um, and the next section was about vectors, how to add two vectors, subtract two vectors, and some properties of vectors, scalar product, scalar multiple of a vector, and so on. Then in the third section, 12.3, we saw how to dot product two vectors, and then the dot product, uh, and we found that dot product was a scalar. Now we are going to do another product known as cross product, which is a vector. So what is the algebraic definition of cross product of two vectors? The vector A has components A1, A2, A3, and vector B has components B1, B2, B3. Then the cross product of A and B is the vector A cross B, vector A cross vector B. Remember that it is, as it is written bold, we don't write that bold, but when you write, you have to make sure that it is a vector. So which means that you have to have an arrow on top of A and B. A cross B um, is this big expression A2B3 minus A3B2, comma A3B1 minus A1B3, comma A1B2 minus A2B1. How to remember this? So we will figure out how we can actually easily remember this cross product of two vectors. Notice that the cross product A cross B of two vectors A and B, unlike the dot product, is a vector. For this reason, it is also called the vector product. Note that A cross B is defined only when A and B are three-dimensional vectors. You cannot define A cross B for a two-dimensional, or only if you have two-dimensional vectors. Now, before we actually get into how we actually remember A cross B in a better way, we need to know a few definitions. The determinant of order 2 is defined by, suppose you take a 2 by 2, two rows and two columns. The determinant is the symbol here. This stands for the symbol determinant. So if we have a 2 by 2 matrix, and if you want to find out the determinant of that matrix, then you have to only multiply left to right, that is A times D, and subtract right to left, BC. AD minus BC is a value of order 2 determinant. Order 2 means two rows and two columns. And determinant of order 3, which means three rows and three columns, can be defined in terms of second order determinants as follows. So what we are going to do is when you expand the determinant of order 3, you can either expand through first row or through first column. So we will choose the expansion through first row. So you have to always go with positive sign for the first element, then negative sign for the second element, positive sign for the third element. So we are expanding through first row. So first row, first column member is associated with positive. Then the second one is associated with the negative, and the third one is associated with positive. So we will write expansion as A1, and then delete the row and the column to which A1 belongs. Then you take the determinant of the remaining. That will be B2, B3, C2, C3. Then you take minus A2, then determinant, then you remove the column and the row to which A2 belongs, and then you will be left with B1, the determinant, B1, C, B1, B3, C1, C3. Then A3 goes with the positive sign. Then you hide the column and the row to which A3 belongs. Then you are left with B1, B2, C1, C2. And then we can expand this determinant, the determinant of order 2, like this will be B2 C3 minus B3 C2. Like that, you can expand the rest of them. So if we now rewrite definition 4 using second order determinants and the standard basis vectors I and j, we see that the cross product of the vectors A, which is A1i plus A2j plus A3k, and B1i plus B2j plus B3k is A cross B, with the determinant, the first row being ijk, second row being the components of A, which are A1, A2, A3, third row being the components of vector B, which are B1, B2, B3. So if you go back to the previous step, this will be A1 times this, then minus A2 times. If you expand this, you're going to get B1 C3 minus B3 C1, then plus A3 multiplied by, when you expand this, it's B1 C2 minus B3 C1. If you notice this expansion, this is the value of the determinant, which is 3 by 3 determinant, 3 rows and 3 columns. That's the way you expand the 3 by 3 determinant. So A cross B can be considered this way. If I expand this, I would get, so I choose to expand through the first row, so plus minus plus like that. So it will be equal to I times, you will have A2 B3 minus A3 B2. So when you do I, you need to remember to hide the first column and the first row to which I belongs. Then expand with the negative j, then you go from left to right, hide the column and the row to which I belongs. Then you are left with A1 times B3 minus A3 times B1 plus K, hide the column and the row to which K belongs. Then you will be left with A1 B2 minus A2 B1. And if you notice, it's exactly same as the components that we have written here. So if you write this in component form, that will be A2 B3 minus A3 B2. Then I can take the negative sign here and distribute. So I'll be left with A3 B1 minus A1 B3. Then the third component would be A1 B2 minus A2 B1. If you notice, compare this value and this value, they are one and the same. So A cross B, instead of remembering the first way, we can actually remember this in the determinant way. Then it becomes a lot simpler. So we'll remember A cross B as determinant ijk. Because it's a vector, you need to remember you have to bring in ijk. Then the second row are the components of the first vector. Third row are the components of the second vector. If vector A is 1, 3, 4, and vector B is 2, 7, negative 5, find the vector product A cross B. So we will use the same formula that we said in 7. So let's try that. A cross B. So its determinant I, J, K, first row or the second row, the components of vector A, 1, 3, 4. Then the components of vector B, which are 2, 7, -5. And you write I, then hide the column and the row to which I belongs. Then it is 3 times -5, that's -15, minus 4 times 7, that is 28. And minus J, go from left to right. 1 times -5, which is -5, minus 4 times 2, which is 8. Then plus K times, hide the column and the row to which our K belongs. 1 times 7 minus 3 times 2 is 6. So we get I times -43, -43, then minus J times -13 plus K times 1. So we can write this as -43I plus 13J plus K. That is the vector product A cross B. Now, the next example, show that A cross A equal to 0. So, if you assume the vector A has components A1, A2, A3, then vector A cross A is a determinant ijk. Then the second row are the components of the vector A. Then third row is also components of vector A. So if you use the expansion through row wise, I, j, k, I times, now you're going to multiply A2, A3 minus A3, A2, same thing. Then minus J times A1, A3 minus A3, A1. Then plus K times A1, A2 minus A2, A1. We notice that every component here is 0. They are equal and opposite of each other. So each one is 0. We get 0i plus 0j plus 0k. So that will be equal to the vector 0. So A cross A has to be 0, or cross product of any vector with itself will become 0. Note, A cross B is a vector perpendicular to both A and B. So if you consider A cross B, and you consider the cross product A cross B will be perpendicular to both A and B, and we can prove this by, we can actually show this by doing the dot product A with A cross B would be 0, and B dot product with A cross B would also be 0. And earlier in dot product, we said that two vectors are perpendicular if their dot product is 0. Because we are claiming that A cross B is perpendicular to both A and B, we will be able to prove that A dot A cross B equal to 0. The vector A cross B is orthogonal to both A and B. So that's what we said here. Now, what is this right-hand thumb rule? The right-hand thumb rule gives the direction of A cross B. So have this picture. If A and B are represented by directed line segments with the same initial point as shown in the figure. So both of them have the same initial point, let's say A, and B have same initial point 0. Um, the, then the cross product A cross B, points in a direction perpendicular to the plane through A and B. It turns out that the direction of A cross B is given by the right hand thumb rule. If the fingers of your right hand curl in the direction of rotation through an angle less than 180 degrees from A to B, then your thumb must point in the direction of A cross B. Look at this figure. So your fingers curl. So look at this figure. The fingers curl from A to B through a rotation less than 180 degrees. Then the thumb actually points the direction perpendicular to the plane containing the vectors A and B. What is the geometric definition of cross product? If theta is the angle between A and B, where theta lies between 0 and pi, then the length of A cross B, the length of the vector A cross B, is length of A times length of B times sine of the angle between the two vectors, where theta is measured from A to B. Earlier, when we did dot product, we said A dot B is length of A times length of B times cosine of the angle between the two. Now, for cross product, it is length of A times length of B times sine of angle between the two vectors. As a corollary, we can say two non-zero vectors A and B are parallel if and only if A cross B is equal to the zero vector. A cross B is the zero vector. The dot product said something about orthogonality, meaning perpendicular condition. A cross B gives us a condition for parallel. So the reason being, if the two vectors are parallel, then the angle between them is either 0 or pi, then A cross B would be length of A times length of B times sine of theta, where theta is 0, theta equal to 0 or theta equal to pi when the two vectors are parallel. So in either case, sine theta equal to 0. That's why the two vectors are parallel if and only if A cross B equal to 0. The length of the vector A cross B of cross product A cross B is equal to the area of the parallelogram determined by A and B. The length of the cross product A cross B is equal to the area of the parallelogram area of the parallelogram determined by A and B. Determined by vector A and vector B. How is that? So let's say you have a parallelogram whose sides are vector A and vector B as shown in this figure. The area of the parallelogram is actually uh, the side, one of the parallel side times height. So we can consider here one of the side as vector A. So its length is its length, which is the side, times height. But what is the height? Height is this part. From the figure, it is equal to. So the vector B is making an angle of theta with A. So Sine theta would be equal to opposite over hypotenuse. So we get sine theta equal to height divided by length of B. So height would be equal to length of B times sine of theta. So height, this height here can be replaced by length of B times sine of theta. This says that it is A cross B, the length of A cross B. The length of A cross B is the area of the parallelogram determined by A and B. This idea will be used later on. So you need to memorize the formulas. The formula that you need to memorize, what is A cross B, length of A cross B, how you can define it algebraically and geometrically, and then how length of A cross B is nothing but the area of the parallelogram determined by A and B. So this is part A of 12.4, part A video. Then we will be continuing with this material. Also, I wanted to point out that problem number 29 is done in the video part of section 12.4. So refer to the video part. Videos for section 12.4. So we will continue with next part of 12.4 in part B of concept video.